As you learned in chemistry, all matter is made up of tiny atoms. All atoms fall under a type called an element, and most atoms are found in the form of what are called compounds, which are essentially groups of atoms bonded together. But any more of that is irrelevant because it's chemistry, and chemistry is magic. However, to understand physics, you gotta know a little bit of magic. So there are four states of matter: solids, liquids, gases, and plasma, though the last isn't relevant for this section. We know that the volume of solids and liquids will always be relatively the same, liquids simply changing their shape. So based on the density, we can find the mass. Meanwhile, a gas does not have a fixed volume nor a fixed shape. Continuing on, say you have a ball at the top of a ramp and it's just sitting there. At this position, the ball only has potential energy, but if you push it a little and make it roll down the ramp, the potential energy is converted into kinetic energy. The total energy of the ball in this system is known as the internal energy, which is basically the sum of the potential energy and kinetic energy of an object. The internal energy differs from the temperature of an object, which is the measure of how hot or cold an object is and is measured using the Celsius or Kelvin scale. When putting two objects with different temperatures in contact with one another, the heat from the hotter object transfers to the colder object until the objects reach a state where they reach the same temperature, also known as thermal equilibrium. As most of you know, there are three types of heat transfer: conduction, which is transferring heat through direct contact between the objects; convection, transferring heat through fluids; and radiation, which is transferring heat without heating the material in between the objects. Depending on the mass and material of the object, it might take a greater amount of energy for an object to heat up or cool down than a different object. This is the thermal capacity, or the amount of energy required to increase the temperature by 1 degree Celsius, and is shown by the formula Q equals lowercase c delta T. Comparing objects made of the same material, a bigger and a smaller one, logically the bigger one would take a longer time to heat up or cool down than the smaller one. Not to be confused with thermal capacity, the specific heat capacity only deals with the material of an object and is the amount of heat required to increase the temperature of 1 kilogram of the material by 1 degree Celsius. The equation Q equals Cm delta T, where C represents specific heat capacity and Q the amount of energy absorbed or released, shows or represents the specific heat capacity. However, the specific heat capacity does not include the amount of heat needed for changing the state of an object. For changes of state, we use latent heat, which is the amount of energy required to change the state of 1 kilogram of an object by 1 degree Celsius at a constant temperature, and is shown by the equation Q equals ml. The units for latent heat are in joules per kilogram. When an object changes state, the kinetic energy of the molecules increases or decreases depending on whether energy is added or taken away from the object. To make solids into liquids and liquids into gases, you have to add heat, but there are two distinct processes in which liquids can turn into gases. The first one, evaporation, is when liquid turns to gas at only the surface of the liquid, and when this happens, the liquid cools down because the high kinetic energy liquid particles leave the system, leaving the normal average kinetic energy in the liquid and making it also decrease. Meanwhile, the second one, which is boiling, is when the entire liquid has the same kinetic energy and liquid changes into gas throughout the liquid, not just the surface. Moving on, this diagram is known as a phase change diagram. As energy is added onto a solid object, say a piece of ice, the temperature of the object continues to increase until the ice experiences a phase change. Up until this point, the object's kinetic energy increases, but while the ice experiences a phase change, the kinetic energy stays constant while the potential energy increases. That's why in the diagram, as the energy added onto the ice increases, the ice's temperature also increases. But when it becomes melting ice, the ice's temperature stops increasing as well. The same thing happens when water heats up and becomes a gas. The changing of solid to liquid, or vice versa, is called fusion. The changing of liquid to gas or vice versa is called vaporization.